access to this for the future, okay? So we have a quadratic that we're gonna say is in the bottom of our integral. So I'm gonna use yours. So 3x squared plus 10x minus 8. Okay, so factors of 24 that add to 10, negative 24 that add to 10. So I'm guessing what, 12 and 2, negative 12 and 2? That would work, right? You can break it apart like that. 3 times 8 is negative 24. And then negative 12 plus 2 equals, make the 2 negative. Okay, so I'm trying to find the way we can break it apart, right? So in breaking it apart, I break this apart into, and I forgot some notation up here. Here we go. Okay. So the goal is to find the integral of this rational function. And the first step that I need to do is actually look at a way of breaking apart the denominator. Since you helped me out by giving me a factorable quadratic, that's the goal. Let's go ahead and say this is, I'm going to do the group and factor method. So 3x squared plus 12x minus 2x minus 8. Right? If you haven't seen that before, I'm just riffing on what we teach our Algebra 1, Algebra 2 students. These two together combine to make 10. This is still structured like it is. So here we have a common factor of 3x, leaving x plus 4. Here we have a common factor of minus 2, so leaving x plus 4. In other words, that quadratic will factor into this structure. 1 over 3x minus 2 times x plus 4 and the integral therein. Okay, that's the setup. Well, that's part 1 of the checklist. Can we rewrite the denominator as a pair of factors? And the skill here is partial fractions. Okay, and there's a lot to this one, so I realize the time crunch. Well, okay, so first of all, if this is our original expression, cool, awesome, right? But we can't use a u substitution. Saying that the entire denominator is u will require a du, and there's an embedded function in there. We can't just magically make a function appear in the integral. That's not allowed. Only providing a constant that you can then take out, that's okay, because that's part of the rules of integrals. Making a 2 show up there to make a 1/2 on the outside, the 2 and the 2 would cancel. That's okay to do. But to put an x there so that we can put a 1 over x, no, you can't. You can't use x functions inside and outside like that. That is bad. That's bad math. So we're going to use this when we recognize that we have this as a resource. We're going to use this as our strategy. The thing is, we're able to take that integral, in fact, just the expression, and write this as 2 integrals. We have a little bit of a problem we need to resolve, but I'm going to go ahead and show you part of what we can do that's okay. We can write this as the integral of, I'm going to use a capital letter. It's because it's habit when I solve these problems. It's in your textbook, okay? A over 3x minus 2 dx plus, I don't know if it's plus, but I'm going to assume plus, and then the sign of the next letter will handle that. You catch that? So the whole thing went from a quadratic to a factored quadratic to now taking that quadratic where those 2 things are on the bottom and writing them as their own integrals. This is going to be really easy to do a u sub with. U equals 3x minus 2, du equals 3 dx. We're not introducing another letter. I'll get to the A and the B here in a second, okay? Keep that spotted. If we know what A and B are, then this is a really easy integral to solve as a really easy integral because it doesn't have a lot of depth to it. It's just like a natural log. Same thing over here. With this integral, we could say u is x plus 4 so that du equals dx, and we are pretty much done, right? That whole thing becomes the u, and the integral of something over u is natural log. What's a and b though? That's the problem. So let's do a little bit of work on the side, okay? Let's take the fact that a, we don't know what it is. It's a number, right? It's gonna be a number like -1 or something. We're gonna take the fact that a is a value and over 3x minus 2, we're gonna add to it. This is the partial fraction skill in action. I don't know when you would have learned it in previous class periods, maybe Algebra 2, maybe pre-calc. Honestly, whenever they're discussing time left in a course that you need to cover, this gets cut right away. And only because like 10 of you a year make it to Calc 2, you know, we're roughly those numbers. It's like we're not harming enough kids to really make it be like something we need to be concerned about. Here's the truth. This fraction plus this fraction actually equals 1 over, it's a lovely noise. It actually equals the original fraction that we started with. So this thing, when you combine the partial fractions, you're back at where we started. That's the idea we're going to keep in mind all the way through. Now, if I have this thing over here, which is technically the factors 3x minus 2, x plus 4, right? This is the same thing. And over here, I have their factors, they're separate. It's like I need to find a common denominator. Because I have two fractions, you have to find common denominators to add fractions. So this fraction is missing this denominator. Might as well add it to the top and bottom. I want to be able to combine the fractions. This is going forward to circle back around to come back up through the middle and tie it's a whole convoluted thing. Over here, this fraction is missing this factor. So we're going to put this in. We're going to put in x plus 4, plus sign a little more over. By doing it top and bottom, we're staying balanced. We're not really changing anything. But now we have a common denominator underneath everything. So ax, well, I'll write it with parentheses first, plus b times 3x minus 2. This is now the new numerator. It'll help us figure out what a and b are. It's all being divided by the common denominator. Common denominator. But we still have what it originally equaled. It equaled this, 1 over 3x minus 2 times x plus 4. So the whole goal of this is to figure out, okay, I need to know, I'm going to scroll up for a second. I need to know what number goes here of this fraction and what number goes here of this fraction so that together those two fractions would add up to the original. That way, if I know what number goes here, this is a really easy integral to solve. This is a really easy integral to solve. So then I have a simpler problem, or at least I have a path moving forward. Let's go back down to this one. This process right here is to find what a and b are. This equation has the same denominator, so let's not worry about it. I mean, it's equal on both sides, right? You have equality on both sides. So what we really have I'm just going to go over to the other side of the board, which is in this case is the other side of the room. See if I can read it. A times x plus 4 plus b times 3x minus 2 equals 1. Let's expand it all the way out. Ax plus 4 times a plus 3bx minus 2b equals 1. I've intentionally not written something over here. There wasn't an x, right? It's just the number 1. There never was meant to be an x. That's what, what we started with. But what happens with this problem, here goes, I'm going to put you up on the podium. What happens with this problem is that over here are some ax, bx relationships. That's part of the whole partial fractions process. So somewhere over on this side of the equation, we need to have the x that goes with it because these two things have to add together to make 0x. That's the only way that would have worked. There was an x in the thing that multiplied a. There was an x in the thing that multiplied b. But the original part of the problem, the numerator of that whole fraction, did not have an x with it. So we're just acknowledging that it was there all the way along. It was just 0. As in ax plus 3b equals 0. Keep that in mind. The thing that's left, those are numbers. I mean, I'm telling you, A is a number. We're looking for a number that will go on the top. We're looking for a number for B that will go on the top of their partial fractions. So 4A minus 2B equals 1, because that's what was there all the way along. Now, here, does it really matter if there's x's everywhere? I mean, if you divide by x, the only condition that we're not dividing by 0, and we're not dividing by 0 because that would be bad, and x is not 0 for magic reasons right now. So these cancel. Remember when you had to solve 2 equations with 2 unknowns when the last time that happened was? Honestly, probably for as long as you guys have been in high school, that was a middle school concept. Use your middle school knowledge right now. Tell me what A is and tell me what B is. What would you do? I would do this. I focus on getting A equals negative 3B. Then I would put this for A in the other formula. So 4 times negative 3B minus 2B equals 1. Combine like terms. So negative 12 minus 2 times B. In other words, B is the fraction negative 1 over 14. Take this back up to this problem. Make the B be that fraction. 3 over 14. Knowing those two numbers, okay, screenshot time. Knowing those two numbers, we're going to take them all the way back to the other side of the room. Here it goes. It is recorded as well, right? So as horrible of a presentation in the moment this is, sorry you're still here, but thank you for being here. We're going to replace A with the number that we just found out on the other side of the room. 3 over 14. We're going to replace B with the number we found on the other side of the room. Negative 1 over 14. Now what we have, this needs a better rewrite. What we have is an integral with a coefficient in the front of it all. Bring the number out front. I mean, maybe there's a reason to leave it in, but for this problem, I'm going to take it to the front because it's just, I'm seeing ahead of the problem to know 3/14 integral 1/3x minus 2 dx minus 1/14 integral of 1/x plus 4 dx. Do you think you could find the integral of this integral or of this one? Maybe that's the thing to think about for tonight as part of your practice for R6. That is the bell. Oh my gosh, thank you for sticking with all the way.